There are several types of backup generator systems available for home use. These can generally be categorized into three main types. Firstly, automatic generator systems with mains disconnect. Secondly, manual generator systems with interlock. And thirdly, standalone generator systems. Let's explore each type, along with some example models, ballpark costs, and relevant National Electrical Code articles. The first type is automatic generator systems with mains disconnect. These systems automatically disconnect the home from the main power grid during an outage and start the generator. An example of this is the Generac Power Pack G5500. This system provides 5.5 kilowatts of backup power. It includes an automatic transfer switch and has remote monitoring capabilities. The installed cost typically ranges from $4,500 to $6,000. Another example is the Briggs & Stratton Elite Series 10000. This system provides 10 kilowatts of backup power. It features a digital display and smartphone connectivity. The installed cost typically ranges from $7,000 to $9,000. The second type of generator system is manual generator systems with interlock. These systems require manual operation. A switch must be thrown to select either the main power grid or the generator as the power source, ensuring that both cannot be active simultaneously. This prevents backfeeding, which can be dangerous. An example of this type is the Champion Home Standby Generator 7500 watt. This generator provides 7.5 kilowatts of backup power. It comes with a manual transfer switch and a 30 amp circuit breaker. The installed cost typically ranges from $2,500 to $3,500. Another example is the Ryobi 5500 watt generator. This generator provides 5.5 kilowatts of backup power and offers 120/240 volt output. It includes a transfer switch interlock kit. The installed cost typically ranges from $1,800 to $2,500. The third type of generator system is standalone generator systems. These systems involve directly plugging essential appliances and devices into the generator instead of using the home's outlets. An example is the Honda ER3000ES. This generator provides 3 kilowatts of backup power. It is known for its ultra-quiet operation and fuel-efficient design. The cost typically ranges from $2,200 to $2,600. Another example is the Yamaha EF3000 ESE. This generator provides 3 kilowatts of backup power and utilizes inverter technology for clean power output. It also features user-friendly controls. The cost typically ranges from $2,700 to $3,100. Now let's delve into the relevant National Electrical Code articles. Article 702 covers optional standby systems. Article 705 addresses interconnected electric power production and distribution systems. Article 708 covers critical operations power systems or COPS. Regarding the cost associated with these generator systems, it's important to understand that they can vary significantly depending on several factors. These factors include the size of the generator, the type of generator, the brand of generator, the complexity of the installation, and local labor rates. These are just ballpark figures, so it is important to get a proper estimate from a licensed electrician. For Type 1 automatic systems, the costs generally range from $5,000 to $10,000. For Type 2 manual systems, the costs generally range from $2,000 to $4,000. For Type 3 standalone systems, the costs generally range from $1,500 to $3,000. It's essential to remember that the best system for a particular home will depend on the specific needs of the household, the budget available, and the existing electrical layout. Therefore, it is highly recommended to consult with a licensed electrician. A qualified electrician can assess the home's electrical requirements, evaluate the various options, and determine the most suitable system to meet those needs. They can also ensure that the installation is performed safely and in compliance with all applicable codes and regulations. Here's some more detailed information about the code articles mentioned. National Electrical Code Article 702, titled Optional Standby Systems, covers the installation and performance of optional standby systems. These systems are intended to supply power to designated loads in the event of failure of the normal power source. These systems can include generators, but are not legally required, hence the term optional. Article 702.4 covers the capacity and rating of the optional standby system. The capacity of the standby system must be adequate to supply the entire load transferred to the standby system, or the load supplied by the optional standby system shall be determined by a qualified person or persons, and be based on the following: firstly, careful determination of the maximum kilowatt demand; secondly, a minimum kilowatt demand; and thirdly, the load and time duration characteristics. Article 702.5 covers the transfer equipment. Transfer equipment, including automatic transfer switches, must be suitable for the intended use and be designed and installed so as to prevent the inadvertent interconnection of normal and standby sources of supply. Article 702.11 covers the signals. Audible or visual signal devices must be provided for the conditions stated below. Firstly, derangement of the optional standby source; secondly, carrying standby load; and thirdly, not carrying standby load. Article 705 addresses interconnected electric power production sources. This article provides requirements for interconnected power production sources operating in parallel with a primary source of electricity. These sources can include generators, solar photovoltaic systems, and wind turbines. Article 705.4 covers equipment approval. All equipment used in interconnected power production systems must be listed and labeled for the intended use. Article 705.12 covers point of connection. The point of connection of the interconnected power production source to the premises wiring system must be suitable for the intended use and must not create a condition that could overload or damage the electrical system. Article 705.16 covers available fault current. The available fault current at the point of connection must be determined and must not exceed the interrupting rating of the overcurrent protective devices in the system. Article 708 covers critical operations power systems, also known as COPS. This article applies to power systems intended to supply power to critical operations areas in the event of a power outage. Critical operations areas include, but are not limited to, hospitals, emergency services, and data centers. Article 708.4 covers equipment approval. All equipment used in critical operations power systems must be listed and labeled for the intended use. Article 708.6 covers capacity and rating. The capacity of the critical operations power system must be adequate to supply the essential loads served by the system. Article 708.8 covers transfer equipment. Transfer equipment, including automatic transfer switches, must be suitable for the intended use and be designed and installed so as to prevent the inadvertent interconnection of normal and emergency sources of supply. Article 708.10 covers overcurrent protection. Overcurrent protection must be provided for all circuits in the critical operations power system. Article 708.12 covers wiring methods. Wiring methods used in critical operations power systems must be suitable for the intended use and must be installed in accordance with the requirements of the NEC. Article 708.20 covers testing and maintenance. Critical operations power systems must be tested and maintained in accordance with the manufacturer's instructions and applicable codes and standards. Keep in mind that electrical codes and regulations can vary depending on the specific location. Always check with local authorities and a qualified electrician to ensure compliance with all applicable requirements. In addition to the NEC articles mentioned, there are other relevant sections of the code that may apply to generator installations. For example, Article 250 covers grounding and bonding, which are essential for safety and proper system operation. Article 445 covers generators, including requirements for sizing, protection, and installation. Article 480 covers storage batteries, which may be used in conjunction with generator systems. Article 700 covers emergency systems, which are legally required for certain applications. Article 701 covers legally required standby systems, which are legally required for certain applications. When selecting a generator for home backup power, it is important to consider the following factors. Firstly, power needs, secondly, fuel type, and thirdly, noise level. Power needs involves determining the amount of power needed to run essential appliances and devices during a power outage. This will help to determine the appropriate size of the generator. Fuel type refers to gasoline, propane, or natural gas. Each fuel type has its own advantages and disadvantages, so it is important to choose the one that best meets individual needs. Noise level refers to generators that can vary in noise level, so it is important to choose one that is not too disruptive. In addition to the generator itself, there are other components and accessories that may be needed for a complete backup power system. These include firstly, a transfer switch, secondly, wiring and conduit, thirdly, fuel storage, and fourthly, a generator enclosure. A transfer switch is a device that allows you to safely switch between utility power and generator power. Wiring and conduit are needed to connect the generator to the transfer switch and to the appliances and devices you want to power. Fuel storage is necessary if you are using a generator that runs on gasoline or propane. A generator enclosure can help to protect the generator from the elements and reduce noise levels. Here are some additional safety tips for using a generator. Firstly, read and follow the manufacturer's instructions carefully. Secondly, never operate a generator indoors or in a garage or carport. Thirdly, make sure the generator is properly grounded. Fourthly, never refuel a generator while it is running or hot. Fifthly, store fuel in a safe place away from heat and open flames. Remember that installing a backup generator is a significant electrical project. It's not just about plugging in a device. It involves making critical connections to your home's electrical system, handling potentially dangerous voltages, and ensuring that everything complies with local codes. If any part of the installation is done incorrectly, it could lead to serious consequences, including electrical fires, electrocution, or damage to your appliances. A licensed electrician has the necessary training, knowledge, and experience to perform the installation safely and correctly. They understand the intricacies of electrical systems, are familiar with local codes and regulations, and can ensure that the generator is properly sized, installed, and grounded. They can also advise you on the best type of generator for your needs, taking into account factors such as your budget, power requirements, and fuel preferences. Moreover, a professional installation will ensure that your generator operates reliably when you need it most. They will test the system to make sure it's functioning properly and provide you with instructions on how to operate and maintain it. Attempting to install a generator yourself may save you some money upfront, but it could end up costing you more in the long run if something goes wrong. Not only could you damage your electrical system or appliances, but you could also void your homeowner's insurance policy if the installation is not done by a licensed professional. In conclusion, choosing and installing a backup generator system requires careful consideration and expertise. It's not just about buying a generator and plugging it in. It's about understanding your power needs, selecting the right type of system, ensuring safe and compliant installation, and maintaining the system for reliable operation. By consulting with a licensed electrician, you can ensure that you make the right choice for your home and that the installation is performed safely and correctly, providing you with peace of mind during power outages. Remember, electricity is not something to be taken lightly. When it comes to your home's electrical system, it's always best to err on the side of caution and seek professional help.